Welcome back to the deep dive. So today we're doing something a little different. Usually when we talk about the AI revolution, all the focus is on the code, right?
Right, it's the chatbots, the agents, all the shiny stuff.
Exactly, the stuff that happens on a screen. But today we're going to completely ignore the software. We're putting the code aside.
Uh-huh.
Because the real story, and frankly the real crisis, isn't on the screen. It's happening in the basement. It's in the utility closet. It's the concrete and the copper.
It is the physical reality check that the digital world just wasn't ready for. And honestly, if you aren't paying attention to the plumbing, you are missing the biggest story in the market right now.
So let's set the scene a bit. We're in January 2026 right now. And we're looking at a bunch of reports that show AI adoption it's huge. About 80% of employees are using it.
It's mainstream. The adoption is there.
But the infrastructure, the actual physical world that has to support all this, it's starting to crack.
It is. And that's really the core idea of this whole deep dive. We have to stop looking at AI as just a tech trend. If you're an investor or a city planner, you have to see this as an infrastructure crisis.
So the limiting factor isn't ideas anymore.
It's not ideas. It's not even chips anymore, really. It's electricity. It's cooling. And it's the actual design of the buildings we're in.
Okay, so that's our mission today. We want to figure out why the market seems to be mispricing all of this. We've got, what, 3 big areas from the research?
Yep. First, what we're calling the power cliff for data centers. Then, the kill list for office buildings.
Which is a terrifying name, by the way.
It is, but it's accurate. And finally, the hidden risks inside so-called smart buildings.
Okay, let's start with the big one, the power.
The power cliff, yeah.
You found a stat in the research on data center demand that, I had to read it twice.
It's pretty staggering. The projections show data center power demand is on track for a 175% increase by 2030. That's compared to 2023 levels.
So almost tripling the demand in just 7 years.
Right. And you have to remember, we aren't talking about plugging in a few more cars. We're talking about gigawatt-scale campuses.
Gigawatts, that's a word I associate with sci-fi movies.
Chuckles.
Right.
Yeah, but now it's just a standard unit for the AI economy. These are facilities that use as much power as a small city.
Yeah.
All day, every day.
And that's where the problem starts. You have the demand side, the tech companies moving at lightning speed.
At the speed of software. But the supply side, the grid, it moves at the speed of, well, utility regulation.
Which is not fast.
Painfully slow.
Yeah.
And that's the conflict. You've got estimates of, what, $1 trillion in new data center investment in North America alone by 2030?
The money is there. The will is there.
The money's there, the chips are there, but they're hitting a physical wall. The industry has a name for it. Time to power.
Time to power. Okay, break that down for me.
It used to be, the main delay in building a data center was how fast you could pour the concrete. Simple construction. Maybe 18 months, tops.
Right.
Now, the timeline is completely dictated by the utility company. We're hearing stories where developers have everything ready to go, and the utility says, great, we can get you a transformer in 3 years.
3 years, just for the transformer.
Yes, if you're lucky. Part of it is supply chain. Everyone wants the same high voltage gear. But a bigger part is just grid congestion. The lines can't handle the load.
So it's like we're trying to build these gigawatt-scale factories, but the utility company takes 3 years just to install the plug socket.
That's a perfect way to put it. And this has completely changed how these assets are valued. What's the old real estate mantra?
Location, location, location.
Right. Rent per square foot.
Mm-hmm.
Be near the highway, be near the talent.
But that's not it anymore.
Not at all. The new metric is dollars per kilowatt.
Dollars per kilowatt. That sounds like something from an energy trading desk, not a property deal.
They're becoming the same thing. Look, if you have a piece of land with a secured power permit, the location itself is almost secondary. It could be in the middle of nowhere.
As long as it has the juice.
If you have the power, you have the asset. You're not selling space anymore. You're selling access to voltage. It's really that simple.
It's like going back to the Industrial Revolution, where you had to build your factory right on the river for the water wheel.
It's the exact same logic.
Yeah.
The substation is the new river, and the driver is just the insane amount of data. We're jumping from about 10 zettabytes of storage in 2023 to 21 zettabytes by 2027.
Doubling the world's data in 4 years.
And all of it has to live somewhere, in a hot box that needs power and cooling.
So if I'm an investor looking at a data center deal, the first question isn't who's the tenant.
No. The first question is, show me the power availability letter from the utility. Is it real, or is it just a hope? Because without that, you've just got a very expensive, very empty shed.
Okay, so that's the back end, the factories. Let's pivot to where most of us actually interact with all this, the office. Or maybe we shouldn't even call it that anymore.
Yeah, this is where it gets really interesting. All the headlines are still about return to office. The tug of war between bosses and employees. Right.
But the data in these reports suggests that whole phrase is misleading. It's not a return to anything.
What is it then?
It's a resorting.
A resorting. Okay, define that. Because the national vacancy rate is still stuck at around 20.5%. That sounds pretty bad.
It does sound bad, but averages are tricky. The market has basically split in two. Your Class A plus trophy buildings, the new ones with all the light and the air and the amenities.
Yeah.
They're hitting over 80% occupancy on their busy days. They're doing just fine.
So the good stuff is full.
The good stuff is full. But the older buildings, the B and C class stuff, are empty. And they're staying empty.
Which brings us to this kill list. Who's on it?
It's those B and C class buildings, mainly from the 80s and 90s. The gray cubicle farms, the drop ceilings.
We all know the ones.
Exactly. And they're on the list not just because they're dated. It's because they're physically, structurally obsolete for the AI age.
How so? It's not just about not having a coffee bar.
No, it's way deeper than that. It's about their bones. They often have what are called deep floor plates. So a long walk from the window to the core of the building.
Right, which means you have these huge, dark middle sections. They have low ceilings. But the real killer is their weak electrical capacity and poor connectivity.
So their infrastructure can't handle modern work.
It can't. You can't just fix it with a renovation. And the reason this matters so much comes down to the new mass of office demand. The research points to a very specific formula.
I saw this. It's demand equals headcount times attendance rate times space per attendee.
Times this new factor, the collaboration premium.
Okay, that last part, collaboration premium. What does that actually mean?
It's the only thing stopping the office market from falling off a cliff. Think about it. AI is automating all the heads-down work, right? The solo stuff.
Spreadsheet jockeying, the first drafts of reports.
All the stuff you can do from home in your pajamas.
Yeah.
So why on earth would you commute for an hour?
For the stuff you can't do at home, the human stuff.
Exactly. The complex, messy, creative, heads-up work. And for that, you need different kinds of spaces.
So the key soundbite I saw was, the office isn't dead, but the desk might be.
That's it, in a nutshell. Companies are moving from one desk per person to maybe one desk for every two people. But they're taking that saved space and reinvesting it.
Into what? War rooms and studios?
Into war rooms, project studios, immersive meeting spaces. The office is becoming less of a factory for typing and more of an event space for synchronization.
An event space. I like that.
But here's the catch. You can't build a high-tech war room in a Class C building from 1985 with terrible wiring. The building just can't support it.
You can't put a Ferrari engine in a go-kart.
Precisely. So the premium buildings that can offer that event experience are thriving, and the ones that can't, their value is heading towards zero. They're becoming liabilities.
That is a brutal truth for a lot of landlords. But there's another layer here. This whole push for smart buildings, making them more efficient, more connected. There's a hidden risk there, isn't there?
A huge one. It's a Trojan horse. To make a building smart, you have to connect everything to a network. The HVAC, the lights, the elevators, all driven by sensors and AI.
Which sounds good for ESG goals. You save energy.
It's great for efficiency. But what you're also doing is creating a massive new attack surface. And we're not talking about stealing data anymore. We're talking about something called operational technology, or OT.
Okay, what's the difference? IT versus OT.
IT is information technology, your email server. It's about data. OT is operational technology. It's the systems that control the physical world. The valves, the motors, the chillers.
So if you hack IT, you steal information. If you hack OT, you can control the building itself.
You can. If the cooling system is on a network, a hacker could shut it down. Or worse, turn the heat up.
So you could literally make a building uninhabitable.
In hours.
Yeah.
Imagine a 50-story glass tower in July, and someone holds the AC for ransom. It's not a data breach. It's a physical safety crisis.
That's terrifying.
And it's totally changing the risk calculation. The sources are clear on this. OT security is now a fundamental underwriting variable for investors and insurers.
So it's not just an IT problem for the help desk anymore.
No, it's a question for the C-suite and the board. Can you prove your building is secure? If you can't, it might become uninsurable, unfinanceable. If you can't power it, permit it, and secure it, you don't have an asset. You have a liability.
Okay, so let's try to pull this all together for the verdict. We have data centers hitting a power wall. We have a huge chunk of the office market that's basically obsolete. And our new smart buildings are a huge cyber risk.
It's a complete rewriting of the rules for real estate.
So what's the takeaway for investors? What do they need to hear?
The message is pretty blunt. Stop hope underwriting.
Hope underwriting, as in hoping things just go back to the way they were.
Exactly. Hoping that an average Class B building will just magically fill up again when interest rates fall. It won't. The split between the winners and the losers is permanent. This is a structural change, not a cycle.
So you underwrite for this flight to quality as the new normal.
You have to. If you're holding those older assets, you have to make a hard choice. Convert it, gut it, or get out. But waiting is not a strategy.
And what about for cities? This power and water issue sounds like the next big political fight.
It already is. The battleground for urban planning is shifting. It's not about building height anymore. It's about zoning for resources, zoning for power and water.
A resource war.
Absolutely. You're seeing communities push back hard against new data centers because of the strain on their grids and water supplies. We're already seeing moratoriums, and the sources predict that's only going to increase.
So getting the license to operate from the community will be harder than raising the money to build.
Much harder.
Yeah.
And that leads to the final point, which is the governance gap.
Right. The stat that 60% of firms are strategically unprepared for this.
Yeah, 60% of firms don't have what the research calls AI-fluent real estate leadership. They still treat their buildings as just a cost on a spreadsheet.
When they need people who understand physics and technology.
They do. They need leaders who get how a new AI model might change their power needs or how their floor plan needs to change. There's a huge disconnect between the tech strategy and the real estate strategy.
That if your CTO and your head of real estate aren't talking,
You're in big trouble. The companies that figure this out, the ones that use their physical space as a strategic tool to power their AI workforce, they're the ones who will win.
it all comes back to plumbing. It's amazing. We get so lost in the magic of the software, we forget it all has to run on something real.
It does. And the real world has rules. It has limits. And those limits are going to define the next phase of this revolution.
So as we wrap this up, we've gone from the power cliff to the office kill list, from physical buildings to cyber risk.
It all connects back to the idea that innovation is about capacity, not just code.
Which brings us to a final, really provocative thought to leave everyone with. We always just assume technology gets faster, better, cheaper, Moore's law. But when you look at these physical constraints,
The question you have to ask is, are we actually approaching a ceiling? Not a ceiling of ideas, we have plenty of those. A physical ceiling.
a ceiling built out of copper wire and water pipes.
Right. If the digital economy is now completely dependent on these physical inputs, are we getting to a point where innovation stalls, not for a lack of imagination, but for a simple lack of voltage?
Can we actually power the future that we're busy designing on our screens?
That is the ultimate bottleneck.
A huge question to think about. When you look at your own portfolio, your own city, don't just look at the code, look at the plumbing.
Always look at the plumbing.
Thanks for joining us on the deep dive. We'll catch you next time.